soul. And shit.
What's up, hackers? Welcome to Saturday Hacker Day. My name is Taggart, and today we have a lot going on. We're going to be doing some blue team stuff. Of course, we have some more Splunk challenges. If we have time, we're going to do some malware analysis. I'm hoping we get to that because it relates to some of what we want to talk about in the news. But in addition, of course, we're going to start with the day's news, or the week's news, I should say, and there is a ton, so strap in. Hey, Dark Elder, happy Saturday to you. Let's get started with this week in cyber. So, the first story we have was certainly popcorn worthy. I'm sure some of you saw the videos of the FSB arresting Russian ransomware actors, part of the REvil or the REvil ransomware group. This happened yesterday in the early hours of the morning, Russia time, and I have the story from multiple different sources in terms of how, why, what, but the latest seems to be that the FSB, the Russian Federal Security Service, uh, let me just ban this bot. Cool. The Russian Security Service, the FSB, arrested 14 members of REvil and was able to recover something like $5.5 million in cash, 500,000 euros, 20 premium cars, whatever that means. And there's lots of video about the arrest, which of course there is. But one thing I want to call out here is that the timing of this is really, really suspicious. Now, for the longest time, Russia wasn't interested in cracking down on ransomware actors. And I'll also mention that the FSB even said that it did this at the behest of the United States. What? Cooperation between the United States and Russia is not super common these days, so what's going on? If you want to zoom out a little bit, we can't say for certain what's going on, but there's a lot happening in international affairs right now, and certainly a lot going on with Russia in particular. So we have this going on, but at the same time, we have Russian troops massing at the border of Ukraine, preparing for what appears to be a second invasion, even though they won't admit to the first one. And that's our second story, actually, but we'll get there in a second. It does seem as though this was some version of a bone to toss to the United States to kind of appease them and perhaps prevent any sanctions, either from the United States or even perhaps ratified by the United Nations Security Council, because if they can demonstrate to the Security Council or even to NATO, for whatever powers NATO has in this context, to say, look, we are cooperating, we are doing these things. You can't say that we're not. Look at these arrests. They do have some version of plausible deniability here. I'm still extremely suspicious of this just because of the timing. And I don't know, just like the filming was really good. I don't know. There's a lot of it that just seemed too convenient to me. Now, I could be way off the reservation here. I could be way way in tinfoil hat land with this, but it does seem just too. I've been given no reason to trust the Russian government. Basically, is the situation here. The two defendants, in terms of individuals arrested, are Roman Gennadyevich Murmosky and Andrei Sergeyevich Besanov. So watch out for those names to see what happens next with those two individuals. Moving on, but staying in the Central Asia contingent here, we have a cyber attack against Ukrainian government machines and networks that showed a ransomware note that says, Ukrainians, all information about you has become public. Be afraid and expect worse. The sites from this is a defacement attack, is the way that we would classify this. And the sites for the Ministry of Defense and Education are down at the moment. Now, obviously, attribution for this is going to be difficult, but again, let's put this together. We have Russian troops massing at the border. This would appear to be a PSYOPs campaign. Think of it the same way as, papering a city with leaflets before a raid or something like that, there is a possibility that this, what I heard yesterday, listening to some intelligence analysts talk about this, is that these kinds of cyber attacks actually act as a force multiplier for physical incursions, because it not only prevents communication, if there is a shutdown of communications, it prevents communication, of course, by the target. But in addition, if you've already scared the population into not responding or staying in their homes, right, it makes rolling through the streets that much easier. And that sounds like, yes, we're talking about Ukraine, Angel, um, which should have updated. Yeah, there we go. Um, so if you're not paying attention to what's going on in Ukraine, I think especially Western news has been really poor at covering this, and frankly also what's been happening in Kazakhstan, which is why I've been trying to make some noise about it here. But there's a lot taking place, both from Russia in terms of what's going on in Ukraine, also what was going on in Kazakhstan. The situation there appears to have been settled, and by settled I mean that the authoritarian regime appears to have gotten power back, and it doesn't look like further uprisings are likely. But remember, how they did it was by shutting down the internet and killing civilians in the hundreds. So let's not forget that took place. So keep an eye on Ukraine. There may be more cyber news going on there, and I do think that the timing of this, combined with the arrests of the Revil group for the United States, is a little bit suspicious. I have no reason to believe that this is going to be a pattern that we see, that further arrests on behalf of the United States will take place. Okay, moving off of Russia. Really interesting write-up came out just a couple days ago about AWS. And this was a really incredible write-up from Orca Security that talked about, and I'll put the link to the write-up here in chat, about an issue with CloudFormation. That's right, Angel. They could access, according to their write-up. I don't think we've seen the full proof of concept here. And this issue has been patched at this point, but apparently there was a vulnerability in AWS's CloudFormation tool, which brings up cloud assets right from a template, that had unbelievably an XXE vulnerability inside of it. Now, if you're not familiar with XXE vulnerabilities, these are a personal love-hate of mine. XML external entities, wherein an API or a system that uses XML allows external entities to be included, and one of the specs of XML is that you can actually load data from external sources like URLs or even files on the system. So file disclosure, potential code execution pivots depending on how the system is configured. And according to this, they were able to disclose like the Etsy password of the remote machine that the CloudFormation template was running on, and actually get AWS employee credentials like API keys, things like that. Pretty wild. And there is a demo of that taking place, but we don't have the concept, the full code for it. Now, again, this issue has been patched as of September 15th, so the write-up was delayed, and I think that's good. I'm happy with the responsible disclosure here. But according to, now let's see. The quote from the write-up is, "Our research team believes, given the data found on the host, including credentials and data involving internal endpoints, that an attacker could abuse this vulnerability to bypass tenant boundaries, giving them privileged access to any resources in AWS." Now, we have to be a little bit careful with that wording, because what that means is they didn't exploit it to do those things. They just believe it might be possible. And of course, once cyber news gets a hold of that, they're going to run with it and hype it up. And we'll talk a little bit more about the cyber news hype train in a minute. But be aware that didn't actually happen as far as we know. We just think that maybe it was possible that it happened. Nevertheless, a really scary vulnerability and yet another piece of evidence that we have to constantly be vigilant about cloud resources. We cannot trust with blind faith that the developers of cloud tools have all of their security ducks in a row. Okay, this is a cool one. And if you were with us for the Backdoors and Breaches game last night, you actually got a little bit of a taste of this. So, we got a report from the FBI this week that US companies, specifically defense contractors, had been targeted by the Fin7 cyber criminal group. So, Fin means that they're financially motivated, as opposed to politically or they're, nation states just trying to cause trouble. Yes, thank you, Angel. Um, and what's wild about this attack is that the delivery mechanism of the ransomware was via USB stick. Well, we'll talk about what that was, but via USB drive or stick, yeah, sent via the United States Postal Service. So they just sent it in the mail, and then people would take the stick, which happened to be a rubber ducky type device, which if you're not familiar with those, hold on, we'll get there, plugged it in, and then the exploit took place. So rubber duckies are essentially keyboards that exist as a USB stick form factor. So think of them as like a one key keyboard or a no key keyboard. But what happens is you plug it in, it is recognized as a HID, human interface device, by the operating system, and then the pre-programmed keystrokes that you yourself can kind of load flash onto the device start executing on the machine. So you can have it like open up a command prompt, quickly hide it, and start typing a PowerShell command or visit a website. We used to use these in the office when we worked in an office. If somebody left their desk and they didn't lock their screen, to like change their background to My Little Pony or something like that. So great fun to be had with rubber duckies. They're actually an invaluable tool for physical pen tests. But in this case, they were used as a legitimate attack vector. According to the FBI report and the Bleeping Computer story on it, Fin7 operators impersonated Amazon and the U.S. Department of Health and Human Services to trick the targets into opening the packages and connecting the USB drives to their systems. So, first of all, the massive point of failure here was obviously cyber awareness by employees at these companies. They should not be plugging, unknown USB sticks into machines that are connected to a sensitive network. And of course, the real issue here wasn't even a technical failure, it was social engineering, right? That layer 8, where they fell prey to an appeal to authority, right? Whether it was Amazon or HHS saying that saying that, oh, hey, this is important, do this thing. Dark Elder says, always loved taking screenshots of people's desktop and using that as a wallpaper while hiding all icons. I wrote a Visual Basic program in high school that did that, and I put it on all of the computers in the computer lab and got in some trouble for doing so. That was like the first hacky thing that I'd ever done. I called it like sysreg.exe too, so no one knew what it was and how to delete it. Yeah, that was a good time. The pipeline after that was pretty standard. Basically, PowerShell downloaded a second stager and then unpacked a JScript bot, which I can't, like, why are you using JScript? But I guess it still works, so that's why. But nevertheless, it was not a particularly interesting pipeline after that, but the delivery mechanism was fairly novel. So if somebody mails you a USB drive, do not plug it into a network computer or even a computer that you care about at all. I wanted to take a minute to also talk about one of the CVEs from this week's Patch Tuesday. There were, I believe, 6 0 days in this month's round of security updates from Microsoft. One of them had a CVSS score of 9.8, and that's CVE 2022 21907. Now, this impacts the http.sys essentially web driver for Windows. And http.sys is underneath a couple of different things, not just IIS, the Windows web server. It can also be underneath WinRM and WSD API. Anything really on the system that might use HTTP as an interface can use http.sys, and especially if it's coming from Windows. So the vulnerability here has to do with a really weird feature that isn't, I guess, was enabled by default in some cases, but is pretty rarely used by people, which is HTTP trailer support. Now, what that means is if we think about an HTTP message, and we've seen a bunch of them on this stream, we usually break them down in between headers and body. And the headers are things like the host, the actual URL that we're trying to get to, X forwarded for, what else? API keys might be in there, authorization headers, whatever else. Those are at the top of the message. And then there's the body of the message. And then if you have HTTP trailer support enabled, you can just keep putting headers there after the body of the message. That's what HTTP trailers are. And if you have this support enabled, you can do that and the server will interpret it fine. Except no, it won't, because this vulnerability seems to lie in how those trailers are being handled. Hey, Killer, good to see you. And so as soon as this was released, first of all, anytime something gets a CVSS score of 9.8, the cyber news starts running around like the sky is falling. The sky is not falling. First of all, it wasn't this support was not, it was enabled by default in some places, but not everywhere. And I want to be clear about that. The following Windows versions and editions were vulnerable by default. Windows 10, 20H2, 21H1, and 21H2, Windows 11, and Windows Server 2022 and 20H2. Not vulnerable is Windows 10, 1909. And you can check your own system or any system that you are responsible for by looking for the following registry key. It is in the local machine hive. Let me just put that in there. So if you look for HKLM, system, current control set, services, HTTP, parameters, enable trailer support, what you're going to be looking for is something other than zero. Basically something other than zero, or if it exists at all. If it's not set to zero, or if it doesn't exist, that was confusing. If it's set to anything other than zero, and it exists, you are vulnerable. So you want to make sure that that's knocked off, and check to see if you have applications that are using trailer support. I doubt it. It's pretty weird. But again, this is not a vulnerability in IIS. This is a vulnerability in the underlying system that supports HTTP for IIS and a bunch of other systems on Windows. So something to check out, but I think that it was way too hyped up because it was a high CVSS 0 day. There is no proof of concept of exploitation, even though it was classified as exploitation more likely by Windows. We haven't seen a proof of concept for it yet. So at the moment, defenders, you do have some time to patch for this. Make sure that it gets onto any Windows server that you're responsible for. But this is not Log4j2 or anything else like that. It's not even like zero logon. It is not that scary. So I just wanted to calm people down with this one. Okay, I think that was it. There was one other story that I wanted to talk about, but we're going to talk about it in the context of malware when we do some malware analysis today, which is a new kind of malware from Iran. And we're going to take a look at muddy water malware. But for now, we have some Splunk challenges to do. So we started the Splunk Boss of the SOC version 3 last week, and I want to finish it. I don't know about you, but I don't like leaving things like that unfinished, and there's a lot more to learn about Splunk, so let's get started. Yes, Killer, that is absolutely correct. We're going to do some Splunk, and then we are going to do some malware. Okay, so we are on this system. If you want to join us, we are here. Hey, SMF, good to see you. I got to come up with a better way to say your name. But yeah, so we finished up AWS logs, at least the first AWS logs section for this. And what we're talking about is essentially a crypto miner installation, which happens constantly. Crypto miners are probably the most common kind of malware these days that I see that we have to contend with. All right, so just turn off Norton. Very good, yeah. Smithy is fine. Oh, I like it. All right, we'll do that. Just turn off Norton. Yeah, Norton Crypto. I don't know what they were thinking. So in this particular one, we are looking at the machines that may have a crypto miner installed. And we're being asked, what is the name of the second process to reach 100% CPU processor utilization? Imagine using Norton in the year of our Lord 2022. I cannot. Although I have to believe that if John McAfee, may he rest in peace, were still alive, he would be all in on this. What an amazing grift, right? Okay, so I had no idea how to look for CPU utilization in Windows or in Splunk, because it's like, that's pretty odd. At least for my usage of Splunk. So I went and checked out the source types for the Splunk Windows add-on. And it turns out, obviously there's Active Directory, but look, there's also perfmon. And so we're going to see if there's any perfmon stuff in here that we can get at. So it should be index equals bots 3, and then yeah, source type equals perfmon mk, and then I don't know what they have set up, so I'm gonna do star just to see everything that's in there. Oh, and I don't want it to be the last 24 hours, I want it to be all time. Okay, definitely some stuff going on in here. And there is only one source type, it's perfmon mk process, which, fine. But notice that we have a percent processor time, and some of them do have it listed as 100. So I'm going to add that to our search. Processor time equals 100. And they want the second process. So what we are going to do is sort that in reverse order, which we can do with reverse. Now, you can also do it with sort minus time, like time descending, but that's like not helpful. So, or I mean, it's not as clean as just doing reverse, which works just fine. Okay. So the second process, let's see what other fields we have here. Right, we have the host, and we have a process ID, but do we have a process name? First of all, we have a creating process ID of 0. That's unhelpful. Is it? Yee. That log is just numbers. Okay. We have a lot of zeros. We're gonna filter out the creating process ID. Of 0. See, that's much better. Does that look close? Second process to reach 100% CPU utilization. Chrome number 5. All right. So we are getting that stuff right. That's cool. And that's from Perfmon. What is the short hostname of the only Frothly endpoint to actually mine Monero cryptocurrency? It's got to be this, right? Indeed it is. Using Splunk's event order functions, what is the first seen signature ID? Boy, that's a bit of a tongue twister. First seen signature ID of the coin miner threat, according to Frothly's semantic endpoint protection data. Ooh, okay, so time for a new source type. I'm gonna duplicate this and change up our search here. Semantic EP. Okay, so agent file, agent system, behavior file. That's a lot of different source types, so we're just going to do semantic star and look for miner. Monero? Well, what do we have in general? So the question was first seen signature ID of the coin miner threat. So we should have a signature ID. You just bought the domain Splunk Cloud for your ops. Hey, Al. I mean, I think you just outed yourself. Well, to 20 viewers, I guess you're fine. Okay, so we gotta break this down to figure out what the signature is and where it is in this thing. Agent system. Okay, risk file. There's only one of those, and there's 46 securities. Aha! Okay, so here we have semantic EP security file. This is looking a little bit closer to what I want. What presumably this is endpoint, right, and then file-based malware. And sure enough, it is. And again, we're asking for, what is it? The first scene signature ID. So again, we're going to have to pipe this to reverse because Splunk does things in descending time order by default. The community is cool about it. That's right. No snitching on Al. Oh, interesting. So we have a signature string, and is that what we want? Do we want the signature string? No, we want the signature ID. So we're going to, I want to table that. So we're going to do table. Dang it, wrong tab. There we go. I was like, okay, so table SIDS signature ID SIDS signature. Thanks for making that field name ridiculous. Much cleaner. Okay, so the first one was 3358. That feels good. I remember when the first time I took on one of these Splunk challenges, I was just like, wrong, also wrong, also wrong. Did not know what they were looking for. This is going a lot smoother. What is the name of the attack? Well. Is it JS Coin Miner? Oh, wait. It's the whole thing. JS Coin Miner download 8. We're killing it. According to Symantec's website, what is the severity of this specific minor threat? Minor threat. Site Symantec.com. Thank you. Medium. Medium. Very descriptive. Thank you, Symantec. What is the short hostname of the only frothy endpoint to show evidence of defeating the cryptocurrency threat? Well, presumably it's this because it got alerted and blocked, right? Symantec sucks. I mean, I think they all kind of do. It's a matter of public record what vendor my my employer uses, and it's not perfect. It's okay. There are things that I really don't like about it, though. I've had problems with some. And to be clear, when Al says problems, he means as a red teamer, right? So it's we want him to have problems. Not the other way around. Microsoft ATP gives me the biggest challenge. Yeah, I would imagine. We want Al to succeed. We support him. What? Your mind tricks don't work on me. Only money. So it says host sepm, which doesn't. No, that's semantic endpoint protection. That's not helpful. Does it have a host name? It does. bton-l. Wow, that went quickly. Okay. I guess we're going back to AWS now. So, question from the 200 series of the bots data. You asked your question, which IAM user access generates the most distinct errors when attempting to access IAM resources. Right. So we actually did some of this last time, where we're gonna do, what is it? Amazon CloudTrail, and let's just see what we have there. Yeah, I mean the thing with Defender that we found out, right, is that it has for dropped binaries. It has some other privileges, but specifically for dropped binaries, one of the things that it can do that no other endpoint detection and response tool can do is simulate, or emulate, I should say, the Windows kernel. So what happens is, for sample sizes that are small enough, it will load a binary into its emulated Windows API environment. It has like a simulated kernel, emulated kernel, and an emulated Windows API, and it is running your binary to see if anything that it detects by its heuristics as malicious happens. Yeah, like running inside a VM, but much, much lighter. Running Bear, thank you so much for the follow. And so, but there are a couple of gotchas with that from a defense standpoint. One, it is time limited, so if you make it take too long, Defender will give up. That's one. Two, it is looking for its own heuristics about API calls and things like that. If you are circumspect about the way that you're getting to API calls, like you're doing weird name resolution of APIs, things like that, you can bypass it that way. And based on our own research, it also would appear that it just doesn't. Sometimes it'll do network stuff and sometimes it won't. So it's one of those situations that if you do it right, a staged payload actually might do better for you. Pretty wild. But yeah. Okay, so what do we have here? In our AWS CloudTrail, we have event types, right? AWS API call. And so I don't usually trust staged either. And that's traditionally what you don't want to do. But think about what we did, Al, with the Cobalt Strike payload. Like, the way that I was able to get that to work most reliably was by doing two things. One, extracting the shellcode and staging it elsewhere. Like, the Cobalt Strike itself was stageless, but my dropper was staged. It wasn't just by making it thick. I actually refined it so it didn't have to be giant. But we did two things. One, we actually let me link to it. Oh, am I not signed in? That's so annoying. Hang on. Yeah, this guy right here. So basically we do two things. One, we do the shellcode injection as normal, but we are loading it from a separate location and downloading it here. And also we are base 64 encoding it not once, not twice, but 3 times. When we that was where I found Defender stopped yelling at me. After base 64 encoding it 3 times plus the network stage, it's just like, I quit. So pretty simple evasion there. And it's funny because, again, the Cobalt Strike part was not staged. All of that was by itself in the shellcode, but the dropper, like the pre-Cobalt Strike dropper, was staged. Okay, back to Splunk. So we have these AWS API calls. I feel like this isn't really what I want, though, because what IAM user access key generates the most distinct errors, because I want to see errors. Most distinct errors. Now, is this thing S-pathed? I think it is. Okay, so username is extracted. So what we want to do is we want to count by username, comma, error code. And what this should do oh, doofus, chart, count by username, error code. I want, hold on a second. Totally unintentional. Let's try that again. No. Come on. Oh, chart is messing me up, I think. Yeah, there we go. That's what I wanted. The Splunk documentation is actually awesome. It's just getting to it that's sometimes difficult. Chart. Aggregation. Over row split. So it's chart by error code over username. No. Row split. Ag equals by or over well, that's gonna be wrong because it's not case sensitive. There we go. So what I need to do is kind of like a 2-layer here, because what I want to do is I basically want the x-axis of a bar chart to be the diff of by stats and chart in the cases. So stats is going to give me yeah, just the statistics table, but here I should be able to do a visualization. Yeah. There we go. Right? Right, so I want the x-axis to be my users, and I want the y-axis basically to be the count of errors. So by user specifies a field to use as the columns in the result table. Oh, so it's actually count by user error code. Is that going to do it for me? Hell yeah. So Splunk access by far. So let me back that up. So what we just did, for those of you who are not used to malding over stats the way that I am all the time, is so we just made a chart that says we want to collect all of the error codes, but we want to do it by, or all the users, and what we want to count on each one of them is the user. So oh, actually, this might be the other way around. Error code, username. So this is the error code on the bottom. All right, so, okay, so we actually had it right the first time, but it's like grouped in this fun way where we're seeing, oh, let's change the format. Can I do a stacked chart? I can't do a stacked chart? What the hell? I guess they're not installed. A stacked chart would be really helpful for this, right? Because then we could see them all by in one. But this is okay. I mean, obviously, Splunk access is what IAM user generates. Access key. Dang it. Okay, we need to find out what the access key is. Please go away? That was weird. So we need the user identity. Session context. No. User identity. Access key ID. That's what we need. User identity, access key ID. Okay, so we'll go and do that count instead of user. Interesting. It's so tiny because oh, for the love of God. Do I have to pipe this to SPath first? We just had it, but then it went away. You see that? Let's flip these so it's a little bit easier to see. Much better. So obviously this key right here had a ton. AKIA-GKL. Polkla. Fine. Do you need to use others false? I don't think so. Just because that's not going to the others, because they're not in the top 10, right? It's not going to change my result in terms of what the top one was. Crap. When attempting to access IAM resources, though, there's another part of this. When attempting to access. But like AWS API call. And that's kind of what it is, right? Now, it's possible also that we're looking at this in the wrong place. I'm going to check another AWS source type just to see if there's something else. CloudWatch, what do you have for me? No, that's actual system logging. CloudTrail is closer to where we wanted to be. It has the IAM data. All right, Splunk. Okay, thank you. We were there. So let's review the question again. What IAM user access key generates the most distinct errors, not the most errors, the most distinct errors? So what we're actually looking for no, that didn't work. Generates the most unique. In this case, we will do use other equals false. The most distinct errors. One, two, three, four. Unless I'm missing something, it looks like JBQA here is the one that has the most distinct errors. What? I don't know why Splunk makes it so hard to copy this data. Dang it. What am I missing here? One thing that I could do that would help with this is like... I want the count of error code types by user, right? So it's a little bit trickier. Sparkline eval expression, a combination of littles fields operators that represents the value of your destination field. What I really want is like unique values, right? See if that works. Probably not, but maybe. No. Just did 5. One, 2, 3, 4, 5, 6. Oh, crap. This one did 7. Different kinds. I am certain that there is a way to aggregate this a little bit more deeply. And I am getting my butt kicked here. What IAM user generates the most distinct errors when attempting to access IAM resources? The most distinct errors. Some of this is in the wording of the question. This one also did 7. Well, that's the one I just did, right? Yeah. One, 2, 3, 4, 5, 6. That's what I want. Count unique values per field. Stats. DC, distinct count. see. Stats. DC. Oh, but not user. What's the actual thing I wanted? AWS access key ID. User identity access key ID. That looked like that was working, right? Sort minus error count. Okay. What? I feel pretty good. I guess there's 3 tied for... Unless this is like the wrong value. No, it's gotta be. It's the access key ID. They don't want the account ID. Whatever. We're gonna move on. Whoa. Bud accidentally commits AWS access keys to an external code repository shortly after he receives a notification from AWS that the account has been compromised. What is the support case that Amazon opens on his behalf? Presumably that's an email, right? That's not going to be a CloudTrail. Would it? We have stream SMTP. Let's look for just like AWS. Got 11 emails. Seriously? Subject. Interesting that this is not Brewer Talk. Craft Brewer Conference. Come on. Hey, there we go. Got it. Amazon Web Services, new support case. Presumably. Let's look at the content body. Yeah, there we go. Your account is compromised. So dumb. What is the secret access key of the key that was leaked to the external code repository? Please still be there. Yes! um, hey, it was also the same key. Thank you for reusing data for that question. Using the lead key, the adversary makes an unauthorized attempt to create a key for a specific resource. What is the name of that resource? Okay, so now that we have this key, we're going to go back to... no, we're not going back to Cutter. Sorry about that. We're going back to this right here. And we're going to do user identity access key ID equals that. Get rid of all this. And we'll do a little bit better here. Error message. Web admin is not authorized to perform IAM get user on resource. Ooh, interesting. What kind of messages we have? List access keys. Create access key. Create user. Delete access key. Fun. Okay. So, what is the name of that resource? Actually, I think we might have just had it. Create access key. Null web admin, right? Using the lead key, the adversary makes an unauthorized attempt to describe an account. What is the full user agent string of the application that originated the request? Okay, describe an account. That is going to be... Describe an account. That's get user. Elastic Wolf. B7H30 is rating with a party of 9. Why, thank you so much, B7H30. Also known as Theo. My name is Michael, and Husky, aka Matt, is not here, but thank you so much for the raid. Pickle290, thank you so much for the follow. We're doing some Splunk, but we're about to change gears here. And I'm gonna mark this as completed so that when we actually do the last thing, it gives us the fireworks. Oh, thanks for the cheer, Psychopath. I appreciate that. Okay, actually, I have a question for y'all, because this is a good break point. I'm addicted to Splunk. Listen, Christy. There are, as far as I know, like 3 blue team streamers on Twitch. I am one of them. And somebody has to teach all of the aspiring analysts how to do their jobs. It's plainly not going to be the organizations that are trying to hire them. All right, so no one's voting on this. Our plan is to also do some malware today, malware analysis. So it kind of seems like 2 people are interested. Oh, there we go, 3. Thank you so much for the votes, 3 people. Okay. So we're going to pivot then to malware analysis. To do that, the first thing we're going to do is go grab ourselves a sample. Yeah, well, we're going to do as much static and dynamic analysis as we can of our malware sample. And the malware sample that I want to go after today is muddy water. Some of you might have seen the US Cyber Command tweet. It was a little bit confusing because it was like we release malware all the time. But what they were trying to talk about was this muddy water sample from Iran. This is not going to be an intro. Well, I mean, you'll learn some stuff about malware analysis, but no, if you want a full intro to malware analysis, you got to go check out Husky's course. Have I done some stuff on the Log4j patch and why it was insecure? I absolutely have. You should go check out the YouTube channel for old VODs. We have definitely done plenty on Log4j, including demonstration of exploitation. We even live on stream demonstrated that Moodle can be vulnerable to it. Yeah, Husky. Let's go get this thing. Husky Hacks has a course on TCM Academy on practical malware analysis and triage. You should go get it if you're interested in malware analysis. It is the best introduction to malware analysis that there is. Okay, but yeah, so muddy water is a new kind of malware from Iran, it would appear. And detected a wide gamut of entities and governments, academia, cryptocurrency, telecom, oil sectors in the Middle East. The group believes in active since at least 2017. So when we need malware samples, we have 2 places generally that I like to go. The first one is VX Underground. We'll see what they have for us. January 15th. Red Line Stealer. That's a fun one too. See if there's anything here. Nope. But that's okay, because the other place we can go is the Malware Bazaar. I made it short, Christy, for a reason. I want the votes of the people who are paying attention. So we're going to tag Muddy Water. And we have a few samples here. This one's an exe, this one's a doc. That's interesting. So we're going to grab one of the executables and one of the documents, I think. So we get downloaded in a zip. I'm going to put it in my malware samples folder. I'm going to name it too. Yep. And we'll get the doc. All right. Having done so, let's start with the executable. And to do that, we're going to fire up our malware analysis machine. We've got a Flare VM right here. Now, to kind of safety this thing, because obviously we need to do that, we're going to actually, I don't want this full screen just yet. To safety this thing, we're going to modify its configuration just a little bit. In our hypervisor, I have this thing at the moment for updates and things like that, and so that Windows licensing doesn't scream at me, I have it connected to the interwebs as well as my isolation switch. I am disconnecting this right now. So it is now no longer connected to the internet. Not both off. I don't care about the isolation switch being off. Sometimes I want that on. But the isolation switch, by design, does not have a connection to the internet. So isolation is fine. It's a totally non-disconnected, like, ad hoc network. So if I wanted to proxy traffic onto Kali or something like that, that's what I have that for. Thanks. This is actually just kind of like the baby lab. I just bought a full out server with 20 cores, 64 gigs of RAM, 1.8 terabytes of storage that is going to become our actual lab environment. I don't have that set up yet, but it's coming, so look out for that. Okay, so we've got Flare, the Flare VM ready to go here. And by the way, we're going to do something else. We're going to do some dynamic analysis, but again, we want to work smarter, not harder. So to learn a little bit more about this, can I do a video setting up the new lab, please? I mean, to the degree possible, I don't really want to show you my house. You know what I mean? But my plan is to do at least a write-up of setting up the lab. And let me back that up a little bit. Nick Loop and Psychopath, thank you for the follows. Also, let me just check something real quick. Okay. One more. I was going to ask for a Tai Chi live stream after your talk tomorrow. Well, I started streaming on Twitch September of 2020. So insanely, it's been 2 years. Which I like way longer than I thought. Yeah. So somebody else is talking about PancakesCon. Let's talk about PancakesCon. PancakesCon is a free conference going on tomorrow. It is being hosted by the inimitable Leslie Carhart, aka Hacks for Pancakes, and it is a really cool conference. It's happening on YouTube. And there's a Slack for it as well. Basically, the way that the talks work for PancakesCon is that half of the 40-minute talk is on a technical topic, and then 20 minutes is on a passion of the presenter. So I am speaking tomorrow. I'll be speaking at 11:15 on track 2, on 11:15 to noon on 2 things. One, using Zap as a professional. And so, like, good pro tips for configuring Zap to do web app pen testing. And then also a very gentle introduction to Tai Chi. I've been studying Tai Chi Chuan for... Tag is just trolling you now. I actually use it every day. Like, I actually use it in my work. That it gets your dander up is just a wonderful bonus. Love you, Al. But so there are so many amazing talks going on, and there's a CTF as well if you're interested in that. So definitely come check it out. Again, it's free, going on all day tomorrow. And Yeah, so that's what's up with PancakeCon. Now, I will say that we'll have reason very, very soon for some sort of community reward. So if a full Tai Chi stream is what y'all want, we'll make that happen. Somehow. Okay, let me log into Hatching Triage. We're going to work smarter, not harder here, and allow Hatching Triage to do some of our dynamic analysis. We want to do some of our own too, but just to get a baseline so we know what to look for, we can submit a sample to Hatching Triage. Let's give it the PE. And the password for the zip file is infected. And submit. And we can say automatic, but we kind of know we want it to run on Windows 10, 64-bit. So that looks good. Internet access on. All right, looks good. Let's go. Analyze. So it does Windows 7 and Windows 10 by default and a static analysis. The static analysis, I'm really curious to see what it says. Very funny. Look at the Screen Connect client that's happening. And you get a video feed of the lab as it's going. That's so interesting. Huh. So this is an MSI that's getting unpacked. Or at least it appears to be. Similar to Cuckoo. Do you mean, Christy, do you mean the Cuckoo sandbox? Yeah, Hatching Triage has its own, detection stuff, but it's like, it's rock solid. Ooh, look at this. Something happened. Nothing going on there. Now, one of the things that's really kind of one of the drawbacks of using a sandbox like this is that because it has, one CPU and there are other tells that it's a sandbox environment, right? Often mature malware will have those detections first and just kill itself if it detects that it's in a sandbox to prevent this kind of analysis. So we may have just run into that right here where it just killed itself. Killer says, correct me if I'm wrong, but if you write malware, you don't want those pop-ups. I mean, it really depends on what the ruse is, right? And there's kind of a social engineering aspect. If you are, for example, if your deployment is like a fake Zoom installer, which I've seen a ton of, then you actually do want it to look like something. Okay, Pepega Gnar, thank you for the follow, and if my math is correct, you are the 1,000th follower of this stream, so thank you so much for the 1,000th follow. Malware does like to sleep for a period of time. Okay, so we did get a score of 8 on this, so let's see what happened. I have good resources for learning how to do Windows API calls in C. Yeah, I do. Here you go, Al. Oh wow, it's even a 40. It's a 404. This, in all seriousness, though, I mean, okay, Rust being Rust, but the implementation of the Windows API in Rust is legitimately good, and so you can see how they did it. If you want, you can also look at Winim, right, in Nim, to see how that went. If you want to see the Windows API, how the implementation went in here. Certainly easier to read. Okay, so we got a score of 8. Why did we get a score of 8? Executes dropped exe, checks computer location setting, loads dropped DLL. So it actually did the stuff. It didn't care about the sandbox. That's wild. Let's take a look at all that. Looks up country code configured to the registry, likely geofence. Interesting. So if we set up the country code to be, if this is Iranian, if we set it up to be Iran, it might kill itself as well. We can play with that. Enumerates connected drives. Very cool. Now, these are all sort of behavioral signatures. We're not seeing a whole lot of detail. Oh, here we go. That's the overview. This is the actual breakdown right here. That's what I wanted. Yes, just like Russian malware checks for system language. Executes dropped exe, screen connect client service.exe, screen connect windows client.exe. So these are now IOCs, right? We can take those strings and start using them in Yara rules, things like that. Checks computer location settings. That's so interesting. We're going to look to see, when we do the static analysis, we're going to look to see what it expects or how it dies on that. That's really interesting. Loads the drop DLL. MSI exec. Very cool. Enumerates connected drives. Drops files. Modifies registry class. Enumerates processes. Very, very interesting. It creates a system restore point? Interesting. And what does it call out to? Oh, something in France. And where is that? SG. Singapore, of course. Not, showing up, but it's there. That's so funny. But it's Microsoft.com, so instance relay screenconnect.com. So it's US based, right? The screenconnect.com. So it looks like they're using essentially commodities. Yeah, they're using commodity stuff to do their work. That's different. but helps, right? I mean, if your job is to try to just get remote access, use tools that are designed for that. I mean, that comes with some other threads for law enforcement to pull, but I don't know. Okay, so first thing we're going to do is we're going to create a checkpoint on this because we're going to save our game. Getting remote access is super easy. Look at tech scammers. Yeah, for sure. We want to save our game before we actually put any malware on it. Okay, checkpoint succeeded. Great. Our game is saved. Then we're going to go over to our malware samples and load this thing in. And we're going to take a look at the executable first. This is all the stuff that Husky and I were working on. All right, let's bring the muddy water executable over and the doc over. Okay, now we can full screen this. Okay. I am no longer doing Try Hack Me. We were doing some Splunk on Try Hack Me, but this is my own lab. We're doing some malware analysis. So let me fire up a command prompt here. I want to make sure I have OLE tools and stuff on the path. So, Nickloop, we are doing malware analysis of newly released Iranian attributed malware. So we're going to see how it does what it does. We just did a dynamic analysis of it, so we have some baseline to understand what it does. It seems like it installs like a remote desktop application, but first it checks to see what country you're in, and if it's in a country that it's okay attacking, it continues. Oh, cool. So we have OLE dump. Oh, we do. Yes. Okay, very good. Very happy about this. With that, then let's open the executable. Yeah, we're gonna find out. 7-zip. Extract here. Infected. All right, so here's the executable, and we're going to open it with Cutter. My good friend Cutter, which is a disassembler. And this is local. So Nick, this is through Hyper-V. And here's what we have going on so far. This is a Flare machine. It's just like a Windows 10 machine with the Flare stuff from Mandiant set up for malware analysis. And it is sandboxed in that it has two network interfaces. One for the internet, which I'm not using because I don't want it connecting to anything. And one that's for my isolation lab. So if I wanted to do packet capture or things like that, I can do that. But right now I don't have anything up that's interested in that. So this thing is totally encapsulated. Nice and safe. But yeah, I really like Hyper-V. That being said, when we build out our lab server, I'm going to be using Proxmox as our interface to KVM. Instead of Hyper-V, VirtualBox could work too. I know. But I don't know if you've tried using VirtualBox on Windows 10 with Hyper-V enabled, but it is a nightmare because all of the networking is controlled through Hyper-V. For that reason, it's actually a pain to do kind of networky stuff with VirtualBox. Also, it is a software-based hypervisor, not a hardware-based hypervisor. Consequently, it's way slower. Hyper-V is the most performant hypervisor on Windows, which is why I use it. Frio, thank you so much for the sub. Appreciate that. Will you try to edit the VM so that malware doesn't detect this VM? No, not at the moment. First of all, we're not doing dynamic analysis. We're doing static. To see what's up with it. That's part one. And then if I need to, I can do some stuff. Now, the Flare machine does have 2 cores and 8 gigs of RAM. So if it's just doing like a processor count, then I'll have it beat there. But if it's doing things like looking for the names of network adapters and other stuff, like I guess I could change those names if I wanted to. We'll see how it goes. I'll be honest with you, I kind of get more excited by static analysis than dynamic. Just because, I don't know, I like looking at code. All right, so this does what it says on the tin here. Let's take a look first at if it has any imports, and indeed it does. Can I zoom this in at all? I can zoom in the disassembly. Hopefully that's big enough for you. Let's take a look at the imports. Do I have a coding background for understanding the malware, or did I learn as I went along? Kind of both. My professional programming background, which does exist, is largely in higher level languages. Like I did a lot of web development and Python and things like that. But I've been doing systems programming stuff for enjoyment. I do Rust and everything else like that. But in terms of learning assembly, that's very much learning as I go along. And I've been doing a lot of binary exploitation, stuff like that, as a security professional to try to get better at this. So yeah, very much as I go. And it's all self-taught. I haven't had any formal training in any of this. But I used to be a teacher. So what I do have is a lot of knowledge about how to teach myself stuff. All right. So here's our main function. And we're looking at it in the disassembly here, but the great thing about... Oh, sorry. We're not ready for that yet. Let's take a look at imports first. And actually, Husky would already be yelling at me about something. What would Husky already be yelling at me about? I didn't defang the sample. PE Studio's cheating. So let's close Cutter and rename this. Thanks. There's no such thing as choose your tools that works. I know, Angel. I just didn't want to, man. But fine. Now that you've opened that box, we'll use PE Studio. So PE Studio is a tool that looks at... That's right, Killer. To not run it accidentally. Is a tool that loads in PEs, also known as portable executables, also known as Windows XEs, for analysis. And it has its own kind of rules about how things work. And it does a lot of the kind of quick static analysis for you. And one of the reasons I don't love using this on stream is because it's teeny tiny. Hard to see. And I'm offline, so I'm not going to get virus total indicators or anything like that. But also, like, here's the thing. PE Studio is great at determining whether something is malware, but, like, we know that it's malware. Oh, I have the magnifier. I can just use that. I've gone full teacher mode. I didn't buy. I just downloaded screen annotation software. So you can see that it has like resources and other stuff. It's still analyzing, so that's not super helpful. Oh, Oreo Bite. I'm sorry. I saw that question and I totally whiffed on it. Where am I going to host the test servers? My house. It's just one server, and so I should be able to handle the power needs for that. I'm going to put it on UPS and should be fine. I've wired this entire house with Cat 6. Zoomit does support painting on screen. This is an open source tool called G-Ink. Because, you know, open source. But I really like it. Because it just gives me this little toolbar on the bottom, and I've got like different pens, things that I need. Super, super handy. So anyway, and this nice pointer, which is way easier to see than the... mouse pointer is G-Ink Java based? Nope, it's C#. Yeah. Okay. So as you can see, PE Studio, not awesome at this. PE Studio is great for determining if something is malware. We know it's malware. So I'm past that point. So that's why I really wanted to do this in Cutter, because I am now interested in not the what, but the how. Okay. Now, we're going to look first at the imports. What is this thing looking at? So it imports, obviously, kernel 32. What does it use? We have close handle, create file, encode pointer, exit process. So we're learning a little bit of the kinds of things that it's going to do. TLS. Okay. We're not seeing anything wild like create remote thread. That would be a dead giveaway, right? We are, however, seeing get current process ID, get current thread ID, right? Things like that. Now, unfortunately, this thing is stripped, so we don't have any function names, but we do have the main function, and this is where this begins. If we look at our decompiler, not DLL injection, process injection is what create remote thread is used for. I guess you can do it for DLL injection too. Yeah. So the decompiler is going to use Ghidra under the hood to try to make the assembly look a little bit more like a C code base. But honestly, I find it harder to read. What we're looking at here are the variables that are getting defined, right? We have code in 32, code in 32. We're assigning them with load library, get proc address. And looks like 40, this function here is our entry point. 401010. Have I ever used .peek? Yes, too much hassle I have. .peek, however, is just for C# assemblies. And I don't know that this was written. Yeah, this was written in like C or C++. Yeah. I don't have any reason. This doesn't look like C# to me, based on the way these are written. This looks a little bit more like it was done lower level than that, C or C++. So, that's what we're gonna do. So 4010, this is what looked like our entry point. Now, one of the things that we can use in our imports is look for that registry call, you know? Get proc address. Let's see what other strings we have loaded in here. See if any strings are clear here. Probably they're not, right? Good malware encodes a bunch of this stuff. There's the function names, date stuff, alphabets. Here we have some language stuff. Yeah. English. I don't think so, Angel. I don't think this is ransomware, number one. This is, if we look at the muddy water here. Here's the Cybercom press release about this. Muddy Waters is subordinate element within the Iranian Ministry of Intelligence Security. And if we go to the virus total alert, this was what kind of drove me crazy. It was like, here, you can have these samples. And I was like, what samples? These are just hashes. What are you doing for me? I mean, I do. Hey, Pi Treason. I have no idea how you want me to pronounce that, but thank you so much for the follow. I mean, I'm logged in here, but I'm not paying. Scary that half of them don't pick it up. Yeah, well. Yeah. We already got the sample, right? That's what we did at Malware Bazaars. We went and got the muddy water stuff from yesterday. As a matter of fact, hold on, let's do a hash match. 5B, 4F. No, slightly different. Like, I don't know. These are tagged as muddy water. Malware Bazaar is pretty good about this. So anyway, we have a sample. This is what we're looking at. So in terms of language, though, Angel, my initial thought on this is that they are using a list of languages that they're cool with targeting. And they are making it hard to... So instead of saying, look for this language and ignore it, they're saying, look for all these languages and then go for it. Yes, I'm looking at a malware sample. So it's country. It's not just country code because it's country plus language code. So like here, there's like English US, English ZA. So it's like English, but it's also localized still, right? English Canadian. Right, a bunch of different Spanish, Espanol, right? So it's language plus localization. So, oh, that's the one that I didn't expect to see. FAIR, that's Farsi Iran. It's Iranian city. This is Iranian malware. But yeah, if we look for RU, there it is. Yeah. So this might just be every language country code. So this might not be the... So we're going to maybe check for it. You know what, though? Let's see. So we found that Farsi IR. And if we believe that this is... Yeah. So one of the cool things you do in Cutter, right? So if we have reason to believe that they're checking to see if Farsi IR is like what they're not going to target, let's look for show cross references. Dang, no cross references. Let's keep looking at our strings, see if there's anything interesting here. Ooh. The PDB is in here. You love to see it. Thank you, Jay Morgan. Oh, wild. I think that they've like embedded an entire binary in here that gets extracted. I think that's what we're seeing. Right, so there is a .NET runner to, who was asking about, yeah, too much hassle. There may be a .NET assembly in here, even if it isn't the first thing. Screen Connect core. Yeah, look at this. There's the Screen Connect, so we saw the sample run. Notice where it says this program cannot be run in DOS mode way down here. So obviously there's another PE embedded in this thing. That's interesting. Right, so the rest of it's going to be Screen Connector stuff. Very interesting. So it has the malware embedded in it. So we're looking at kind of the dropped stuff at this point. So let's go back into our disassembly here. File name. Time. This is all kind of preamble stuff. And then we go to 4010. We also have a graph that can walk us through a lot of this. Right, this is the logical graph for this whole main function. All of this is within that. And then we have the call to whatever this function is here, which has its own... Oh, it's kind of like by itself. It has another call, though. So we're just going to walk through this function here. Find resource. Load resource. Loading data, calls this function. This is hard to see, and once we're just doing a lot of these moves, let's check the decompiler for this. Wow, that's ugly. We have a switch table. Okay. Look at these int3s. I think Angel knows what these int3s are about. Yep. Soft breakpoint. Correct. That's why I like the assembly. It don't lie. Alright, so the only way out of this function is through this function call here. So let's move through this to see if we have another call in here. A lot of returns, but these are case statements. Interesting. Unless I missed something, let's go back to main here. There was just the one function call, right, to 4010, and then a return. And from 4010, I only saw the one way out. The call, unless there's something funny going on here. Well, let's look at the graph for 5520. Oh, okay. Yikes. But these are all within that same function. Interestingly, these are all the conditionals, basically the branches that the code can take within that same function. Crazy to look at, right? I heard you like trees. I mean, I do. I'm from Pennsylvania. We all like trees. What I really want to see is like the compare to the language. And in fact, let's go back to the hatching triage report, because I want to see the registry keys that it was hitting. Right. Registry users, control panel, international geo nation. See if any of that is available. It may be encrypted one way or another. We can look for a string like that. Impersonation. What about geo? Nope. All right, we got some registry stuff going on here. Which is actually kind of what I wanted. Can't see any of the cross references here. We're way at like the bottom of the code here. Yeah, this is wild. I can't make heads or tails about this, unfortunately. I'm looking for something to see, like, matching the language, but let's move on. I mean, even though I can't see a way out of this function, let's take a look at some of the other functions we have here listed. In order, right? Some of these are really short. Right. I think some of this stuff might happen before we get to the main method through entry 0. Now, I think we also have Ghidra, if we wanted to try to open this up in Ghidra. I don't know how much better it's going to look, though, to be honest with you. Because these functions aren't named, right? So, unfortunately, we're not going to be able to, like, get names of functions here. And a reason for not using IDA, I like this better, and I'm not paying for IDA Pro. Wherever possible, I try to use open source tools. And IDA just went to like a crazy subscription model that's even more upsetting. All right. Well, what we might do is refang this thing. I mean, it's the standard if you can afford it. Okay. Let's get Process Hacker up and running. And again, this is why we sandbox this. We're going to do some dynamic analysis and see what Process Hacker has to see about this. Ooh. I don't actually want that to happen. Fine. All right, here we go. Running malware. Well, that straight died. Well, I do like to do static analysis, but it's not the only tool in our toolbox. There's screenconnect.client running and MSI exec. Here we go. Let's see what's up with this. So this is what the handles it's looking for. Oh, look at that. It's Control Panel International. Slightly different registry keys. And look, we're seeing it run with a bunch of different... Look at that. We're seeing it run with a bunch of different command line params, right? We're seeing it run with, like, domains and stuff. cmofa.gov.kw. Or c equals mofa.gov.kw. Looks like access keys. That's really neat. And while we're there, let's go to Procmon so we can see what it's trying to do. So we're going to do a filter on process name contains screen connect, add that filter, apply that filter. Interesting. Thread create. So it's already been installed to program files, right? Very interesting. Now, because it's using Screen Connect, now we've got this domain here. That's an indicator, right? So let's go look that up. Could the second can't run in DOS mode be the installer for Screen Connect? We believe that to be what it is, yes. Or at least I believe that to be what it is, yes. Anything suspicious on TCP view? Great question. Do I not have TCP view? I guess I could fire up inetsim and permanently, you know, break my... Hold on a second. Go to... netstat NOP. So with the interface disconnected, it's not going to help me that much. What I need to do is like simulate the network connection. And to do that, I would need to use FakeNet. And then I would start seeing stuff. Can I affect my broadcast quality lower? You should be able to drop it down. I'm doing 5,000 bits, and I'm not going to change that. Sorry, Peter. That's actually a lower bitrate than Twitch recommends for 1080p. Specifically because I was trying to make it a little bit easier to consume, but still keep 1080p. HL4 and Swift Hit, thank you so much for the follows. I honestly don't know how to add other options. Like, I've set up my bit rates to be as tolerable as possible. Someone can tell me. Yeah. If I know that if I drop my bit rate to 4,000, then it goes to 720. But anything above that, and it'll default to 1080 as my source. It's weird, though, that it doesn't give you the ability to change it. But yeah, I mean, that's kind of on them after I give them the raw. All right, so we still have this screen connect. Only partners have options. Oh, cool. Well, not much I can do about that. All right, let's try to fire up FakeNet NG and see what we see here. This is always fun because it totally breaks stuff. No, that's affiliate, killer. There's affiliate and partner. Thanks, Angel. Thanks for the link to the TTPs. Ooh, we're getting some requests here. 239, that's something. Let's terminate this. Terminate this. And run that again. Why not, right? It didn't even delete itself. The following application should be closed. That's so funny. All right, let's see what it does now. What happens if you simulate a connection to that IP port? Well, first of all, we can just look up this IP. Oh, here we go. We're getting stuff. We're getting the requests for screenconnect.com. So this is the thing. It's like legitimately Screen Connect. So they're using like off-the-shelf software for this. This is all the stuff that we saw before. 239, 255, 250. That is a weird one. It's a multicast address. That's what I thought. No, it's a multicast address. Yeah, this range is, first of all, 255. You should be, that's multicast, right? That's weird. That it's doing that. But I think that might be because, oh wait, yeah. Duh, Taggart, come on. Screen Connect is going to use a multicast group to do its broadcasting. That's I think like a load balancing technique. But this relay is interesting. Yes, it's Screen Connector making the request. Hey, look. We are starting to get some detections for this particular relay for Screen Connect. 9048, right? And if we look for, let's look for 9048. What's this doing? Yeah, but SVC host doing what? Come on. Oh, actually, this might be legit. SSDP serve. Yeah. Where's Procmon? Yo, look at all the registry stuff we got from Screen Connect this time. Really cool. Okay. Where are you seeing a buffer overflow, Killer? In the results? I'm not sure what you mean by the results. Oh, over here? Buffer overflow? That is interesting. But it's a query, not create or anything. I want to see if I can filter path contains geo. So it's looking for, this is Screen Connect. Let's get rid of the process name filter. There it is, right there. That's really small. Let me see if I can zoom that in for you. Oh, God. Used the wrong magnifier. Right there. Reg key, control panel, international geo, nation. And it's setting info. What it set it to. Tags information. Then it was just querying it. Right, and obviously it found it. And then look. This is where it's doing all of the opening for language packs. It's looking for every single one of them. So our next steps with this would be probably to do something like... Our next step with this would be something like attach a live debugger to it. Wait to see this process monitor, the registry query happen in the live debugger, like WinDBG or Immunity or something, and then go to that memory space in Cutter to see what's actually happening, to see if we can look for what it's looking for. And I will try to do that quickly. But to clean everything up, what we're going to do is we are going to restore this poor thing to its previous checkpoint, because we made a mess, basically. And that's why we make checkpoints. That should be in your standard operating procedure if you're doing a lab, right? Always have a way to do snapshots or checkpoints of your environment so that you don't break stuff. All right, let's put WinDBG back into our downloads. Now, by the way, in terms of, we're doing malware analysis, we're doing some research. Sharyuga, by the way, thank you for the follow. We're doing research. If you wanted to do this for a result, right, looking for indicators of compromise, we've already found some good ones. We've already found, for example, some domains that we can use. I believe that the Screen Connect key may well be kind of static to this. It's entirely possible. I would also, frankly, in terms of detections on the network, I would be super suspicious of any calls to screenconnect.com at this point. That would be something to look for in your DNS. Remote viewing software, especially in an enterprise, should be verboten. I was gonna say, like, with some exceptions, but no, not really. Team Viewer, Screen Connect, any of that stuff, just shut it down. Yeah, absolutely a hot mess. All right, let's extract here. Infected. Okay, so we're gonna get Procmon up. Take your time, Windows. I do have WinDBG installed. And this is the preview version. It's kind of interesting. It comes from the Windows Store. I have immunity too, but I'm trying to get used to using this just because I'm interested in where it's going. So it's kind of why I'm using this. All right, let's get Procmon up and running. Process Hacker wasn't doing as much for us in this context, so I'm going to stay with Process Monitor. And we're going to start filtering for path contains geo add, and we're going to say process name contains, and even though it's not running yet, we're going to add that as a filter because we're going to wait for it, right? All right, in WinDBG then, file, launch executable. Here we go. Now, we already saw some of this. The Jack Black, thank you so much for the follow. We saw this int3 when we were doing the disassembly in Cutter. And in fact, let me fire up Cutter as well and load the exe. Process monitor hasn't done anything. The reason we want to do this is we want to, here's my DBG. All right, we're loading this up. We saw these int3s, right, inside of our disassembly of this. We saw a bunch of int3s in not the main, but 4010, right? Yeah, we saw a bunch of these. And yeah. That's gonna, so we call that, we add 4 to the stack pointer. Move the stack pointer to the base pointer, pop the base pointer, and we return. But it's a return with an offset. That's interesting. Okay. So we're gonna step over this. We hit another breakpoint. We hit another breakpoint. Oh, here we go. Now we're moving again. All right, continue the function execution. How we doing, Procmon? Continue. Continue, continue. Uh-oh. Only one part of a read process memory, write process memory was completed. Let's restart it. I see why the int3 is stuck. Yeah. Let's go handle its exception. There we go. Aha! Thought we saw some of those. So we saw it happen. We saw it happen. Could we breakpoint it on it and change it? Maybe, but I'm also just interested to see what this is. Now, hey, Maticus. Good to see you. Let's restart it and see what the disassembly has to say. Let's go handle exception. B72. I want to see if the offset is sane. NTDLL SEH prolog 4. I want to see where this is in here. Imports. No. Not going to see it in here, I guess. Presumably we saw it happen again. We did. So this is how it's avoiding some of the, if I'm understanding this right, the WoW64 system service call. NT access check. Touch page for write. All right. It's getting at the registry, I think, in a kind of deep and weird way, rather than doing the registry API. Yeah. Okay. Too far. This is pretty deep in the weeds for me. sprintf. I'm looking for anything that looks like, okay, string. There's a compare here. All right, I want to look for this opcode. EDX dword pointer. Let's see if I can find that. And luckily, I can actually search for opcodes in Cutter. See if... There we go. What was it? It was compare EDX to EBP minus 14. We're in main still. If this is the same one. This is after all those int3s, though. The problem is I don't know what the offset for any of these is, right? The difference is... I need to okay, so like, how many of these int3s are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's a lot more. Here we go. Maybe 1, 2, 3. Okay. So we're going to do a little X math here. What's the difference between these two addresses? What I'm trying to do is find where we are in the code so I can see it in Cutter. And to do that, I need to understand how the debugger and... Okay. So let's confirm. Let's see if we got this something like right. Well, obviously, this is going to give us the right answer, right? Yeah. So, okay, so if this is the offset, then we want to find another thing in the code in WinDBG, and if we can match it to something else in Cutter, we'll know that we have the offset correct. Which, tricky. Try to find something that's pretty obvious. We might still be in... Oh, you know what? Yeah, we might be all over the map here. I think I'm reaching my limit for what I can do here. reading this without knowing a lot more about how the NT-DLLs are imported and used. So it's time for me to do some more research if I want to follow on this, and I can do that and will. But I think, you know, we've done a little bit of solid static analysis here. We found through dynamic analysis the screen connect thing. Is there anything else anyone wanted to see today? Just while we're here, anything else in the malware? We also saw that it was checking for geo IPs. Jaya, thank you so much for the sub. Angel's got some more cyber intel for us. POW goop variants. Any persistence? Yeah, I mean, that's the thing. It installs itself as the Screen Connect viewer and launches itself as a service. So we did see that. Interesting, because this is not matching what we saw in our samples at all, basically. What we saw was really straight ahead. It's possible we had like older samples. But still, pretty cool to check out. We'll do some more of this, especially as the lab gets more mature. And frankly, I get better at it. But I think this is cool to see, you know, how this breaks down and what you actually have to look at to see this happen dynamically. But we did see, you know, the international geo get checked. We would need to really dive in to see, you know, where this is happening and what language it's looking for to see if there's a kill switch somewhere in here. I suspect that there is, and that helps with attribution. But it's definitely looking for everything because we saw those reads, right? If we do go handled exception, right? Or if we restart this, go handled exception. Let's do this one more time. Yeah, fine. Automatically close it. Go. We see Procmon. Oh, let me clear that filter. Right, after it looks for geo stuff, it looks for all kinds of language stuff as well. Create file mapping to MSI exe. Is there like a file write we see in here anywhere? Because where's the MSI? Create file. Common proxy stub. Interesting. File map. Oh, there you go. It creates MSI exec. So this is a fake MSI exec in syswow 64. That's how that's happening. So it looks like MSI exec, but it isn't really. That's clever. Do I want to try to edit those and see if it still runs? Edit what? Oh, the geolocations? Well, we don't know where they are yet. Oh, well, I guess we know where they are in here. Yeah, if you're saying like rewrite those to change those codes. Not really, because I wanna see them actually happen. But yeah, I think this is a good start on this. We'll play some more with this, and you know, maybe I can convince Husky to come back and do some of this with us. But I think for now we're gonna call it a day. Let's see if there is anybody else who is streaming. But before I go, once again, if you're interested, come check out PancakesCon tomorrow. It's going to be an absolute blast. Join us at pancakescon.com. Already, Christy, it's been 2 hours and 45 minutes. Yeah. I got stuff to do. All right. Looks like my buddy Ira Sakai is streaming, so let's check them out and see what they're up to. Doing some Nikto stuff. That looks cool. All right, we'll send you over to Ira Sakai. But then, yeah. Until next time, friends, be good to yourselves, be good to each other, and happy hacking. We'll see you later. Peter, that's just RDP with Hyper-V. Just share clipboard.